The dot product of vectors given in component form. Previously, we talked about the scalar product, multiplying a real number, which we call a scalar in this context, times a vector. We talked about vector addition, adding two vectors together. We have not looked at the combination of multiplying two vectors together. And it turns out there are a couple of different ways that are useful, but the one that is the most common is called the dot product. And it's named like that because we use the multiplication dot to represent it. So if we have two vectors, and let's again call our vectors u with components ux and uy, and let's have a vector v with components vx and vy, then the dot product u dot v is going to be a scalar value. When you take a dot product, the result is a real number, not a vector. The dot product gives a real number value, not a vector. And we calculate it by multiplying component by component. We will multiply our u's, or our x components together, ux times vx. We will multiply our y components together, uy times vy, and then we will add the results. So the dot product is useful to us as a way to take vectors and turn them into a scalar value. There are a couple of very nice properties of the dot product, which we don't have enough time to talk about this semester, that you will probably see in future courses, if not in a future math course, then in a physics course or other applied science course that takes advantage of your new knowledge of vectors. But remembering the process is not the most straightforward, but using the process really is. So if I have two vectors, like say 8, -7, and 9, -5, then to dot these vectors together, we will multiply the x components. Which is 8 times 9 in this case. We will multiply the y components, which is -7 times -5 in this case. 8 times 9 is 72, -7 times -5 is positive 35, and add those together we get 107 as the dot product of these two vectors.